Hey coders, welcome back. In this video, I'm again going to take one of the assessment from the LeetCode. So if you don't know, you can go leetcode.com/assessment, and they have this available even in the free account. So you can select from online assessment, phone interview, or on-site interview, and the questions are generated randomly, right? And the questions are from the real company. So you can basically give a mock test at practice. So I think I'm giving like three. I have recorded three, four videos. Some are from OA, some are from phone interviews, some of them are from on-site one. So today I'm going to solve this phone interview section again, and let's see how it goes. And my video is recorded, and but it is unedited. It is not edited or nothing is being changed. And I'm going to see the questions for the very first time also, so I have no idea what questions are gonna come. So hopefully you will see the solution from as a real world. I mean, we are going from the scratch, try to understand the problem step by step, find the right kind of data structure and algorithm to solve this problem, right? So that's the idea of this video. So let's start with this phone interviewer. So if we have three questions, we have 1 hour and 30 minutes to complete, right? So let's start. Okay, my internet is slow. I don't know why. Yeah, okay. So we have two questions. So let's see the very first question. It says, given an array of integer, return true if the number of occurrences of each value in the array is unique, right? Otherwise, return false. Okay. Let's read this question one more time just to understand it better. So we have an array of integers and it can be positive or negative, and the numbers in the array are length from 1 to 1000. Okay. And then if the number of occurrences of each value in the array is unique, then we have to return true, otherwise false. Now, for this example, you see, we have like one, okay, let me zoom out. Okay, so in this example, we have something like 122 113. If I say the frequency, and the frequency of 1 is 3, okay, 2 is 2, and 3 is 1. So no two value have the same number of occurrences. That's why we return, right? So that's the idea. So we basically just need to count the frequency of each number, and then we just need to iterate over each frequency and see if there is duplicates or not. There are a bunch of ways you can solve this. Either you can use map, or even you can use a simple array to store the number, because the numbers are ranges from -1000 to +1000, right? So maybe you can create an array of size 2001, right? And 0 will represent -1000, right? So 0, so if you see a number like -1000, you add 1000, right? So in each number you're gonna add 1000, and that will give you the index, and that will be, I mean, if you see the time complexity, even for that case, it will be same. So it's easier if you go to use our map data structure, right? So let's solve it quickly. I don't think we need to discuss a lot on in this one. So I just get the length of the array, and I'm gonna create our map, right? So integer of integer, basically key and value gonna be integer. And let me create quickly, okay, my hash map, and then I'm gonna iterate over each array, and then I'm gonna count frequency, right? So a one. So yeah, so this is how you can calculate frequency in Java. So we have something called a merge method, right? You can provide the value that you wanted to add. So this is the method that gonna use, and whatever value is going to provide it will be added in this key, right? So like you can also do it something like this if you're not comfortable with merge method. So maybe you can check if map dot contains a, then you can simply say map dot put a, map dot get a plus one. Else you can say map dot put a comma one, something like this. And this is fine too, right? But let's focus on this one. I think this is more cleaner, right? The merge one. So I'm gonna use that. Now what we need to do? Now I need to make sure all the frequency are going to be unique. So for now, we have something like this in our map. One is coming for three times, two is coming for two times, and three is coming one time. Right? Now we just need to extract these value, right? Three to one, and just we just need to make sure this is unique. So how we can do that? Well, we can use set, right? Because set can check a number already exists or not in constant time. So let's create a set, and then I'm gonna iterate over all the values of my map, right? So for int v, map dot values method is there in our hash map, and then gonna add set dot add, can check if set dot uh, contains v, we gonna return false, right? Otherwise we gonna say v, we gonna add, and if we didn't find any duplicate, this means we are good, right? So that's the idea. Time complexity, so since we are iterating only once here, so this for loop is gonna run for big O of n times, and then again we are iterating over the map dot value. So if each numbers are unique, right? So we might need to uh, iterate to each number again, right? So if let's say if we have if we have an array like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when we're gonna have a map like 1 is 1, 2 is 1, 3 is 1, 4 is 1, right? So in the worst case, we might need to travel linear time again. So this is also linear. So total complexity will be linear, right? So it will be 2n, but we generally take the lower bound. So yeah, so here I'm getting true. Let's try submitting it. Okay, so yeah, we are able to submit. So I don't think we need to discuss here any particular data structure or algorithm. Yeah, you just need to be aware of map, and you need to be aware of this set. And you can try without creating map, right? Maybe something like this. You can create something like a frequency array. And here you need to create maybe 2001 size because we have to incorporate this minus 1000 also. So whatever number we get, we iterate here, we are iterating here for int a of ARR. We need to make sure that frequency of a plus 1000 is being used. So plus equals to 1. Why? Because minus 1, there might be a minus 1000. So minus 1000 plus 1000 is 0, right? So basically you can use something called, I think we call it base maybe, and then that will be a little faster than map, right? But yeah, I think we are good with this one. So let's move to the next question. Sorry. Okay, so it says you have n boxes and you are given a binary string boxes of length n, where box size is either 0, okay, no, box is 0 if is box is empty, and 1 if it contains one ball. Okay. Now, in one operation, you can move one ball from the box to adjacent box. Okay. Now box I is adjacent to box j if absolute of I minus j equals to 1. So basically you can move the box from either in the left side or the right side, right? Not like just one place, right? Either in the left or the right. N- Now note that after doing so, there may be more than one ball in some box, and that's true. Okay. Now return an array answer of size n, where answer I is the minimum number of operations needed to move all the balls to the ith box. Okay. Now each answer I is calculated considering the initial state of the box. Okay. So let me zoom a bit. Okay. So we have we have this box. So we have basically three boxes, right? Zeroth box is one, oneth box is one, twoth box is zero. Now the question says what how many minimum operations you need to move all the boxes at the zeroth position, at the oneth position, and at the twoth position. So if you see for this position, we already have one box, so we just need to move this box to its left side, right? So that will be one. Now for again for this position, one, we're gonna move the very first one to its at one, so it's gonna be one. Now for zero, this one needs to be travel one unit, right? So it will come here, and this one needs to travel 2 units, right? So it will come here. So one plus two is equals to three. Similarly, we have this example, different box size. Now the good part is n is 2000, right? So 2 into 10 to the power 3. This means you can write an n square solution for this one. So that's good. So I think the main idea is we have to find how what can be the logic so such that we can move these numbers efficiently from one place to other. So let me see what we can do. Okay. So for each position we need to move all those ones, right? So let's take this one, this middle one, how we can calculate efficiently. So here in the left side, we don't have any one. So that's good. From the left side, we are not going to count anything. Now from the right side, this one needs to be moved, right? So 1 unit and then 1 unit. So it's 2 unit, right? And this one also needs to move. So 3, 4, and 5. So the answer is 5 for this one. Yes, 5 is for this one. Now, how can we define a like algorithmic, basically step by step to do this? So, I mean, it feels more like we just need to calculate the position and I'm seeing the constraints. It says 2 to 10 to the power 3, so n square solution will be sufficient. We will try with n square first because it is will be acceptable, and then we will try to maybe optimize it. So what gonna be the core logic? Maybe from one, I can start two for loop. Basically, one is for this, one is for this, and then try to find out right how many movement we need. So will that work? I think that will work. Nothing fancy needs to be done. So for example, now let's say we have this arena. We have let's move it a bit closer. Yeah. Let's say I wanted to move all the ones to the very first place. So I will go to this one. What's the difference between these and this position? So this is 2, right? 0, 1, 2. So 2. Okay, so 2 plus. Now how many steps needed to move this one? So that will be 1, 2, 3, and 4, right? Yes. And then how many steps we need for this one? Well, 1, 2, 3, 4, 5. So answer will be 5 plus 4 plus 2, which is 11, right? I think this is look pretty easy. I don't know. Maybe we are missing something or this is the question. Let's try it and maybe we can check. So I will change this first to maybe S, and then I'm gonna create an N. Let's get the length of this string first, and then we need to create an answer of this size. Now I'm gonna iterate over each element. So I is equals to 0, I less than n, I plus plus, and then I have to find out like how many ones in the left side, how many ones in the right side. So what we're gonna do is maybe I can run a simple for loop from j to j plus plus, and if I equals to j, I will simply say continue. Otherwise, I'm gonna create a temp variable which is gonna store the temporary sum for that position. So for example, if I is equals to 2, so we are only solving for I is equals to 2, right? So this temp will contain all the temporary sum for I is equals to 2, right? So if I is equals to j, I'm continuing because let's say I'm at 1, right? So when I will move, try to find all the ones in the left side, I will try to find all the ones in the right side and do the sum, right? If this is, I'm gonna continue, and also if s dot char at j equals to 0, then I also continue because we only need to count one, right? And then I can say temp plus equals to math dot absolute of k minus I. So this is the difference, okay? And after finishing this for loop, I can simply say answer of I equals to temp, and then we're gonna return the answer. Yeah, I think that's it. Let's see. We have any error? Okay, we have one error. I forgot the I. Anything else? No. Let's try again. Okay, I'm getting 113. Before submitting, let's try this one also. And yeah, okay, so 11, 8, 5, 4, 3, 4. Okay, let's try submitting it. Okay, we were able to submit, but before that, as per constraint, this is optimal solution, right? You can write n square. But can we do better? Let's see. Let's try. So for this number, let's copy paste here. What we can do. Alright, so this is the number. What we can do for this one. So let's say if I'm at this position, how many movements I need? Okay. If you see here, let's try to focus only on the right side first. Maybe left side we will calculate later. So for this position to move all the ones, we need all the ones needed from this side, right? So this is nothing but the very next position plus one, right? So how many times this zero, we all one needs to be moved to here, and then plus one, will that work? No, that will be and plus two, no, right? Because we have two ones. So for example, let's say we are calculating for this one and only focusing on the right side, right? For this one. So what will be answer for zero? For zero, we need this one to here, so 1 unit. This one to here, so 2 units, right? So it's like 3 units. And what's the movement for if we are calculating for this one? So that will be 2 units, right? And for this one, 1, 2, 3 units. So that will be 5. So that is nothing but the sum from the very next position plus the number of ones in the right side. Right. So can I use this approach to solve this problem a bit faster? It feels like a prefix sum. Can we do prefix sum? Because ultimately, yeah, this is what we are doing. So for example, for 0, I'm gonna need how many movement we need for this one, right? So I need only need one. Now for this one, it will be 1 plus number of 1. That is 2. Yeah, I think we can solve it using DP kind of. Okay, let's try. Let's try. So I'm gonna remove this. Let me zoom out a bit. Let me see if it is visible. Yes, it is. So as per discussion, let let me copy this example here. Um, I'm gonna create a prefix sum, and the idea will be what is the prefix sum of this? It will give me number of one, and if for any position I'm able to find out number of ones in the left side and number of ones in the right side, can I solve it? Um, and we can reduce the time complexity from n square to n. Let's first focus on the only right side calculation, not the left side, right? So let's redefine our question is like now. Earlier, we can either move this one to the very left, to the very right. But for now, let's focus only on the right, right? So what I'm gonna need? I'm gonna need a prefix plus one size, and let's initialize this prefix, right? So I is equal to 1, I less than equal to n, I plus plus, and then prefix of I minus 1 equals to prefix, um, sorry, we need I equals to I minus 1 plus um, uh, uh, s dot char at I equals to 0, then it is 0, held 1. So this is our prefix sum, guys. So we can basically now get the sum of any subarray in a constant time. So this is good. What else now? Let's create int dpr. So this is basically for calculation of the number in the right side. Only when the movement is only right side allowed. So dp of r for n. Mm, how will this work? I'm not sure. So we create a dp of r. Okay. Mm-hmm. Yeah, I think this is good. And then dpr of n minus 1 equals to 0 because even though how many numbers for the very last element, right? How many numbers we can move, we need to move in the right side to make this happen? Nothing, right? Because we are not going to have anything in the right side. That's why I put 0. And then I'm gonna calculate it from n minus 2, I greater than 0, I minus minus. Now dpr of I equals to dpr of n minus 1 plus, not n minus 1, I plus 1, I plus 1, I plus 1 plus number of ones from this subarray in the right side. Mm, yeah, that will be our prefix of n minus prefix of okay, so let me show you what I'm doing is, let's say we have an array like this, right? And our prefix sum is something like this: 0, 1, then 3, then 6, then 10, then 15, right? Just keep it here only. This is our prefix sum, right? So I'm saying when I'm here, I need to find number of ones in the right side. That will be nothing but total sum minus this plus. Uh, mm, yeah, total sum minus this. So that will be 5, correct? That's the idea. This is how my DP in the right, if your movement is only right side, then this will be give me the answer. Now same we need to create for left side also. So for that, just create DP of left side, new int n, and then I'm gonna say DP of left of 0 equals to 0, and then for int I is equals to 2, I less than n, I plus plus, DP left of I equals to DP left of I minus 1 plus number of ones in the right side. That is nothing but prefix of I plus 1. Right. And then we gonna iterate over each and say something like answer of I equals to dp left of I plus dp right of I, and we're gonna return the answer. Will this work, guys? So I think looks good. Let's try running it. See. Okay, we have issue here. Okay, we have to I minus 1, right? Let's run it again. Okay, so okay, we are not getting expected. So for this, I'm getting 3, 3, 3. Okay, let's see for the right. What is my DPF right? What are the value we have? Raise dot to string, but right. Then maybe we will try to identify what problem. So this is at the right side. Of course, for this one, we don't need anything. Now for this one, this is wrong, right? For one, this should be 1 actually because we have 1 here. So why this is, so I is equals to n minus 2, I greater than 0, I plus plus, okay. And then is equals to I plus 1 plus 1. Now prefix of n, that's wrong guys. We have to put prefix of n plus 1. No. I think prefix is fine because my size is n plus 1. Yeah, and we need to remove from I. That's correct. What's wrong? Wow. So for this number, do I have to do prefix I plus 1? Uh, so 3, 2, 1, and then 0. And if I wanted to get the numbers from here, okay, yeah, I have to do I plus 1 also. Let me see again. No, no, I'm not getting the expected result. Why this is so? So prefix of I. Okay, let's see our prefix there. System dot out dot println arrays dot to string prefix. Let's run it. So this is our prefix array, and this is wrong because we should get two here, right? I don't know why we are getting what I'm missing. Okay, so for I equals to 1, of course it's going to be 0. For I equals to 2, okay. For I is equals to 3, so 0, 1, 2, 3, this will be 1, okay. Now for 4 it should be 2 now. What's wrong? I mean, why? So we are here, I minus 1 will be 1, and plus f dot char at I minus 1. Hmm, what I'm missing? Very silly mistake I'm doing. I'm not able to find why. Are we never calculating this? But how that can be possible? Wow. Prefix of I minus 1 plus 1. That's correct. What's wrong, guys? Quickly, let me do something like this just to test. Mhm. C, and they also gonna print the C. Let me run it. 0, 0, 0, then 1, 0, 1, 1. That is correct. So 0, 0. Then we have a 1. Then why this is coming as a 0? No, no, that's fine. No, but now you see, we are getting 3 now. 1, 2, 3. But why initially we're not getting? Maybe that ternary operator was not evaluating correctly, guys. So, I mean, I don't know what's wrong, but this way it is working. Right. And you see, our answer is also now getting correct. 11865. No, 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 it's wrong. Okay. Here we have getting 7 and 5 and all. Maybe because of duplicates. I'm not sure, but yeah, at least for right side, let's see. Now let me hide this out. Let me comment this prefix array and let's see what is our DPF right now. So this is our DPF right? So if you see, this is 11, this is fine. For this one, this is fine. For this one, this is fine. For this one, it will be 3. That's correct. 1, then 1, 2. Now for this one, it is like 1, 2, then 3, 4, 5. That's correct. For this one, I think our right side is working fine. Our left side has some issue. Now let's see. Let me comment out this one and let's try to understand what I'm missing in the right left side. So dp of left side of 0 is 0 because there will be nothing. And I have to start from 1, not 2. Let's run it again. Mm, no, again this is not right. So dp left 0 is 0. That's fine. Now from I equals to 1, we are iterating and saying dp of I will be dp left of I minus 1, that's correct, plus number of ones from I because we don't want it to take that number as into the consideration. We just want in the left side. So now you see 1185,434. So yeah, this is the more optimized version. I think this will run. You see guys, from the n square solution, we can go to the linear just using a DP and prefix sum. But if you see the constraint, if you're okay with 2000, this should work. So let me try submitting it. Okay, yeah, I see the difference now. We have 119 millisecond to 3 millisecond. So I hope you like it. Yeah, this was good question. If you try to solve brute force, then it was easy. But if you can optimize to linear, this was a bit difficult. I messed up some conditions, but at the end, yeah, we are able to solve it. So I hope you like it. If you have any question or query, you can comment. Thank you so much for watching.